Some of the hardest problems in the world exist far above the planet. Our job? To launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion, to learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
The Artemis program is critical to the future of humanity. We are landing the first woman and next man on the moon.
The architecture is really comprised of three major elements.
Oh, never mind.
We, Lockheed, are building the ascent element. It's where the crew is housed.
The transfer element is to transfer the lunar lander down to the surface of the moon.
The descent element, built by Blue Origin, is really a game-changing moon landing vehicle.
As a partner in the national team, Draper will provide guidance, navigation and control, avionics, and software systems.
And in order to pull this off, it takes a team.
We are designing a vehicle that will be able to ensure humanity has a permanent presence on the moon.
Welcome back. So this is the first of our awards presentations. Throughout this year's symposium, we'll be presenting several prominent awards to some very deserving recipients. In UAH, University of Alabama, Huntsville, I still think I can say Roll Tide with that anyway. UAH is our very generous sponsor for this year's awards presentations. Now, I don't know if you can see this very well, but back in a long, long time ago, galaxy far away, back early program, I was a propulsion engineer. And one of our challenges back then was what happens when we have an OMCAT abort? We start the engines, how long do we, if we stop those engines, what do we have to do to go off and have another flight or another restart? So that was a challenge for us for a couple of years, figuring out all the things we had to do and putting those into a timeline so we'd know how long our turnaround would be. Well, back in 2016, 2017, DARPA created a program called the XS-1 system, where they were trying to get a launch vehicle be able to fly multiple times in a short period of time from essentially a version pad. And one of the problems that came forward very early in that program was, well, propulsion systems won't support that. There's no way that we can do what we need to do to be able to use the same propulsion system 10 times in a row in just a few days. But some of the propulsion systems came forward and said they're ready for the test, and one of these were Aerojet Rocketdyne. Aerojet Rocketdyne's AR-22 engine was tested 10 times at 100 seconds within a 10-day period. Some of the propulsion folks said it couldn't happen, but it did. Despite all these odds, the demo succeeded. And this is the first time a large liquid oxygen, liquid hydrogen engine have been tested at this frequency, requiring a combination of innovation and determination from the entire team. So for their significant accomplishments, the AAS Space Technology Award is presented to Jeff Haynes and the AR-22 team at Aerojet Rocketdyne for an unprecedented demonstration of rapid turnaround of a large liquid rocket engine. Jeff, congratulations to you and the team.
Thank you, Alan. I appreciate it. Like you said, it was a team effort. And also, like you said, a lot of people thought this couldn't be done. This is a very complex liquid rocket engine. It's, flight proven hardware that we cobbled together. It's an older model, space shuttle main engine, essentially. Turning around every day for 10 days in a row over the 4th of July holiday, including a couple of strikes from Mother Nature with lightning hitting the facility and knocking antennas and motherboards off the roof. Created some challenges for us, but the technical team led by Mike Bradley out of Los Angeles as chief engineer, and our operations team led out of Stennis Space Center with Jeff Hansel pushed through it, and we got through this, and doing really hard things like figuring out how to dry the engine completely in a short period of time. I think we got down to 16 hours at one point for a total turnaround and ready to go. So that's a testament to the team effort, and I really appreciate being awarded this presentation for the AR-22 team on behalf of Aerojet Rocketdyne. Thank you.
Thank you very much. from experience, I know it was really a tough time and long nights, long days, and then more long nights. So thank you very much for you and your team. And I'm sure what you learned there will be played forward as we go into the Artemis program and we try to be successful there.